Hi folks. In this video we'll look at how to convert from trinomial form of a parabola to vertex form. And vertex form is typically more helpful because it tells you the key ingredient of a parabola, which is its vertex. So these are three steps that you can use. There are also alternate techniques. You can use calculus, you can use completing the square, but this is typically what I like to do. So notice in both of these functions there's this a value. It means the same thing in both of them. It's the leading coefficient, tells us about steepness and direction of opening. Find the vertex would be our next step. So the x-coordinate of the vertex is negative b over 2a. The y-coordinate comes from sub in that x-coordinate that we just found. And then we can rewrite appropriately, knowing that in this form, the vertex is at h and k. So let's try that out in two examples. In the very first one, we have x squared plus 4x minus 2. There's really a 1 in front here. So if I want to put it in vertex form, it would be really helpful to know the vertex. Right? And we did this in the last lesson. The vertex is going to be at something, something. The x-coordinate comes from negative b over 2a. So for us, that's going to be negative 4 over 2 times 1. And that would give us negative 4 over 2, or negative 2. Great, there's the x-coordinate of the vertex. The y-coordinate of the vertex, I'm just going to sub in negative 2 into this function. So I'd have negative 2 squared plus 4 times negative 2 minus 2. Let's just follow that through. So y is going to be 4 minus 8 minus 2, or negative 6. So now I know the coordinates of the vertex. I know when I write it in vertex form, it's going to go y equals a. Well, hold on now. A here is just 1. So if I want, I can write a 1, but it seems a little much. Okay. Now I have to do x something squared plus or minus something on the end. If the vertex is at negative 2, the temptation is to do this, to say x minus 2. But remember, if you had an x minus 2 all squared, that would mean the vertex x-coordinate is at 2. It is the negative, or the opposite sign of what shows up in that bracket. So if you want a vertex at negative 2, we'd write x plus 2 all squared. The y-coordinate, on the other hand, is just as we'd expect. So allegedly, the equation of this function in vertex form is x plus 2 all squared minus 6, which is frankly more useful than having it in this trinomial form to begin with. The only thing we get out of the trinomial form easily is the y-intercept, but that's pretty easy to find either way. I'm going to go to the graphing calculator and just make sure that these are two different equations for the exact same thing. Here's the graph of x squared plus 4x minus 2, how we were given the function originally. And now in red, it's going to graph it as I give it to it in the new form, which was x plus 2 all squared minus 6. I hope that these are the exact same thing. And you can see that they are. It just traced over the blue one. They're the exact same graph. What that does is confirm to us that we did this properly, that we found just a different way of writing the exact same graph, and that we gave it a more useful form. So there's another one. If you feel comfortable with the technique, pause, try it yourself. If not, we can do it together. Once again here, I've got an a value that's positive. So this is my a is 2. In the end, I'm going to have a 2 by x minus h all squared plus k. Now I just have to hunt down that vertex. So vertex is at something, something. The x-coordinate is going to be negative b over 2a. So be careful here. That's negative 2, because b is negative 2, all over 2 times a. You probably saw this coming. It's going to be a fraction. It's going to be 2 over 4, or a half. That's okay. We've got this. The y-coordinate of the vertex, so the x-coordinate's a half. The y-coordinate, we're just going to sub in a half for x. No big deal. And follow it through. So that's 2 times a quarter minus, oh, let's check this out, 2 times a half. I mean, I guess I could call that 2 over 2, but geez, that's just -1 plus 1. And 2 times a quarter is a half. So a half minus 1 plus 1. Now think about this. Do we really need to go to a common denominator? I don't think so. -1 plus 1, they're gone. Y is a half. That is the y-coordinate of our vertex. So if I put this in vertex form, what I'm going to get is this equation. Y equals, I still need that leading coefficient of 2 because I noted it to begin with. Check out the steps. Note the a value. Yep. Find the vertex. Done. Rewrite appropriately. We're working on it. So I'll have x minus a half, because it's minus the x value of the vertex, and then plus the y value. Okay, so just to be clear here, this half corresponds to this one over here. This half corresponds to the y value. You could go to your GDC and just double check that those actually give you the same graph, whether you graph it in this form or in this form, but they will. So in terms of practice on this stuff, you can check out from the old book, page 35 to 36. I'll leave it to your discretion whether you want to do all of these. It really depends on how comfortable you feel with this. So let's say maybe do a smattering, optionally a smattering. I think you should do these ones over here. If you look on page 35, you'll also see that they show a different technique for getting the same result from completing the square. And I've just found that students in general have a little more success with the technique I showed here. But if you want to check out this alternate technique, that is wonderful too. By the time we're done in the course, we'll have 3 or 4 different ways to do this, this operation of converting to vertex form. I've also had math teachers express dismay that we're not doing it by completing the square. But really, any method that gets you to vertex form is valid. Whatever works for you. I've found that students have had the most success with this method. But do your thing. All right, folks, if you have any questions, let me know, and take care.